In this lesson, we'll be discussing how to find the range of a radical function using the method of algebra. Given that f of x is equal root x plus 1, how do we find the range of these function? Now, we have to rewrite these in terms of y. So we have that our y will be equal root x plus 1. Now we know if we apply the property of square root, we know that x plus 1 must be greater than equal 0 because the restriction states that you cannot take the root of a non-positive value. So we cannot have any negative value in that inside this root. And if this is the case, this implies that our y will be greater than or equal 0. Now we have the values of y. How do we write the range? Therefore, range is that y is a set of all real numbers. Y is a set of all real numbers, but our y must be greater than or equal 0. Or we can write it in set notation, meaning y is a set of all real numbers from 0, because greater than or equal, so from 0 we write that y is from 0 to infinity. Now, because 0 is included, remember it's starting from 0, it must be greater than or equal 0. Since 0 is included, we are going to use the square bracket, right? You still remember that? So this is the answer. Let's take another example. Let's take we have, and you may pause the video and try this out. When you are done, and you can watch the solution. Given that our f of x is equal root x minus 3, x minus 3 plus 2. Now you are asked to find the range. Go ahead and pause the video. When you are done, watch the solution. Now, if we are to solve this, remember the first is we rewrite the function in terms of y. So we are going to have that y is equal x minus 3 plus 2. All right, we want to separate the square root so that we can apply the property of the square root, the restriction, to enable us get the value of y. So this will mean that our y will be equal. We take 2 to the other side of the equation. So our y now minus 2, all right? So if we are subtracting 2 from both sides of the equation, that's the only way we can eliminate 2 from here. So y minus 2 will give us equal root x minus 3. Now if we apply the restriction, that is because x minus 3 must be greater than or equal 0. So, which means that our y minus 2 must be greater than or equal 0. If that is the case, let's look for the value of y. Y now will be greater than or equal to, because negative 2 crosses over the inequality sign, it becomes positive. Now we have the value of y, meaning our range cannot be written as that y is the set of all real numbers, but our y must be greater than or equal to. or we can write it in set notation, meaning that our y, since 2 is included, so our y will be from 2 to infinity. All right, you can choose to write it in any notation except it is specified.